Yesterday we talked about compound angles and milling the corner off of a block. We're going to take a look at a couple of these problems in the packet. We are looking at page 410. I'm going to do problems, 5, 6, somewhere in there. So, problem number 5. We have this angle at this corner here beveled off. Front view is going to look something like that. This angle is listed as 32 degrees. Side view looks something like that. This angle is listed as 38 degrees. We give, again, we're just going to take a guess and put a number in here. We're going to call it 10 millimeters. The actual depth doesn't matter. We're just using that number to do our calculations. So we need to find this dimension here, which we'll call y. This dimension here, which we'll call x, which of course is the same as this dimension here. To find y, if you recall, it is the tangent of 32 degrees equals 10 over y. We have to put this over 1, cross, multiply, and divide. So it becomes 10 divided by tangent of 32. Gives us 16.003. So I'll put it there. So 1 times 10 divided by tangent of 32. Over here now to find x, it'll be the tangent of 38 degrees equals 10 over x, because 10 is your opposite side and x is your adjacent side. We put this over 1 so we can cross multiply and divide. So it is 10 divided by the tangent of 38. Giving us 12.799. So of course this over here is also 12.799. And those are in millimeters, of course. Okay, so looking at this triangle here, we have 12.799 on this side, and we have 16.003 on this side. Our angle of rotation is right here, so we'll find the angle of rotation. Remember, R is, anybody remember? Inverse tangent. The opposite side would be the 12.799 over the adjacent side is the 16.003. So second tangent, 12.799 divided by 16.003. I have to remember to close my parentheses just to be safe. Equals 38.65 degrees. Now remember, the next step is to take this triangle and cut it across there and find that length here. So the triangle we're looking at now is this one here highlighted in yellow. So the 16.003 now becomes the hypotenuse because it's across from the right angle. The side we're looking for, this diagonal here, is one of the legs. It is the opposite side, according to our 38.65 degree angle. So we have opposite and hypotenuse, which makes that a sine. So it is the sine of 38.65 degrees equals the opposite side is the side we're looking for over our hypotenuse, which is the 16.003. So we'll put this over 1 and cross multiply and divide. Sine of 38.65, remember to close your parentheses, times 16.003 divided by 1. So sine of 38.65, I close my parentheses, times 16.003 divided by the 1. Of course, you don't really need to divide by 1. Equals 9.995. Why do you want that length there? Good question. Because to find our angle of tilt, our angle of tilt here is going to be found, if we picture this corner being completed, the angle that we have to tilt this is the angle from that line there. We picture that triangle there? It's this angle here that we got to tilt it. So this line here is that diagonal that we just found. That's this. Because remember, this triangle is looking at this from the top here. So we just found that distance across there, which is this. And we know this depth here, that's what we chose to be the 10 millimeters here, this depth. What that is, here, let me grab the block here. If I take this and I lay a sheet of paper across it to simulate that flat surface, that angle is the angle between here and this paper. Okay. So that's the angle that you would have to tilt this at to make that flat. But you have to measure it in such a way that it's perpendicular to this top edge, so that when you tilt it, that edge is now lined up with the mill. Because you're rotating around this top edge. You're rotating it around that to make this surface flat. Does that make any sense?
So you have to go to the longest piece.
Yeah, you go off of this top edge. Tells you where to rotate. So you're gonna, when you rotate it so that this edge is now lined up with the machine, so that when you tilt, you're tilting, this is actually just rotating that edge. Does that make sense?
It's going to pivot on that top.
Yep, so now what you're doing is, like I said, if you put a surface here, as you rotate it, you're going from the top being flat to the surface being flat. So your angle of rotation is this angle here or this angle over here. It's the same angle. But you've got to be perpendicular to that edge, which is what we found here. This is perpendicular right up here before you can measure down. See what that is? If I can draw my corner a little bit better here, maybe.
I guess I'm wondering why the purple and the yellow line aren't in the same place.
Well, because you're looking at 3 dimensions. Here, let me try to draw it a little better, maybe. We'll see.
The yellow line actually goes to the corner that used to be there.
Right.
The purple one goes to the corner is already too away. And that's the difference between the corner that was there and the one that wasn't.
Yep, that's basically it. See, if you're looking at it like this, these dotted lines are the parts that we're milling away. This here is that perpendicular that we just calculated, right? This is going down the surface after we mill it. So what we're doing is we're taking this length that we just found, the green one. We know this depth, and we're finding this angle here, so we know how far to tilt the table. Or put the bevel vise or whatever.
So when we say that it's 10, we're just picking the
Yep.
number, we're not actually talking the depth of the whole block.
No,
Just the cut.
just the depth of the cut. Yeah, that 10 that we chose just goes to the bottom of the cut. So we just found out, we know that this depth here, we chose it to be 10. This length here we calculated to be 9.995. So now we can find the angle there. This is our angle of tilt right here. 9.995 and 10. So T is going to be an inverse tangent. 10 over 9.995. You got it. So T is 45.01 degrees, pretty much. So you would rotate this block 38.65 degrees. Again, that's just if you're looking at it from the top. If we're lining it up, we're lining it up with this edge of the machine, of the platform, which actually be the bottom of your bevel vise, most likely. You're going to rotate it this amount. Wow, my artistic abilities suck. Let me try that again. So here's our block. Here's the corner we're machining off. We're going to rotate it now so that this surface is in line with the edge. So this is our angle of rotation here. That angle of rotation brings this edge now, so it's lined up that way. And then the tilt, we lift up right here, so that now this is lifted up away from the surface. And that'll lift it up so that this triangular surface here now is flat to the ground, so the mill just mills it off flat. Okay, let's do one more example. Now, like 6, 7, 8, they've got the angles going all different directions. I don't necessarily see the point. To me, just as well keep the angles going the same way. We'll do number 7 here. I'm going to draw it my way just because we'll just keep it standard. Technically they're milling off a different corner, but the calculations are the same. So why not lay it out the same so it stays simple? So the angles we have are 24 degrees and 32 degrees. And again, we're going to pick a number here. I'll stick with my 10 millimeters. So we want to find Y and X. You guys tell me, how do I find Y? Tangent of 24 equals 10 over Y. Good. So I put this over 1, cross multiply and divide. 10 divided by tangent of 24. 2246. Good.
So
You got
why
her.
are we choosing, since you put any number in there, why don't you just have it 1 number?
Because then I get really small numbers to work with. 10 just is easier to work with. Yeah, you could put 1 millimeter in there if you wanted to, but then I'm working with, 0.2 whatever, just really small numbers is all. Over here now to find X. Tangent of 32 degrees equals 10 over X. Good. So I put this over 1, cross multiply and divide. So it's 10 divided by tangent of 32, which is 16.003, good. So now it's this triangle that we want right here. So we got 16.003, 22.460, and we're looking for angle of rotation right here. And that angle, of course, is, yep, inverse tangent of the opposite side, 16.003, over the adjacent side. So second tangent, 16.003 divided by 22.46. 35.47 degrees. Now what do we do?
Take the sine of that degrees we just figured out.
Yep. So we're going to cut that angle across there, and it's going to be the sine of the 35.47 degrees equals that.
Z over
Perfect. If we call that Z over 22.46. So we put this over 1. It's going to be sine of 35.47 times 22.46 divided by 1. So, what's that? 1366 sounds right to me. And yes, oops. Let's say 3547, 2246. I got 13.03. 13033. $13.033. So now again, that's giving us out of this corner here, this that we just found is the 13.033. This here is what we chose to be 10. We're looking for this angle here, which will be the inverse tangent of, perfect, 10 over 13.033. So second tangent, 10 divided by 13.033. 37.498. So 37.50 degrees is our angle of tilt. So we got a tilt of that, a rotation. Remember, the rotation was the 35.47 degrees. So there's our setup right there. For tomorrow, we're going to keep working on this. I want you to finish up the page 409 to page, actually this is 410 is where it starts, to page 411. Try to calculate those out.